Hey kiddos, here's the video going through the feedback for Spiral 6. First off, we've got to graph a parabola in vertex form. I identify my vertex is going to be at 4, 3, and that's going to happen because that's the opposite of what's inside. In other words, what makes the parentheses equal to 0 and the natural part of what's outside, so 4, 3. I know that the basic shape of this should be some kind of a U. It's a parabola because of the squared part. And I also know with a -2 out front that my next 2 points are going to be 1 unit to either side and 2 down. You can only use this idea to work 1 to the right and 1 to the left. So to go further from this, we've got to then sketch a nice graph for us. The y-intercept, which I normally would ask for, I think is going to be really negative here, so we're not going to bother with that. So something like this would be appropriate for your graph. For number 8, you've got to solve an absolute value equation. First thing that we've got to do is to get the absolute value by itself. So let's add 2 to both sides, and we get 8 is equal to 2 times the absolute value of x plus 3. If I divide both sides by 2, that's a terrible looking 2, there we go. I get 4 is equal to the absolute value of x plus 3. We've talked about this meaning 2 things. The first is we have a positive equation where you have 4 is equal to the absolute value goes away to make the positive x plus 3. And then you're going to have a negative version of this equation, which is going to be 4 is equal to the negative absolute value of x plus 3. But I keep saying absolute value, but I just mean the quantity. For the positive version, if I minus 3 to both sides, we very quickly get x equals 1 as our solution. On the negative side, we have 2 different ways we tend to be doing this. A number of you are dividing by a negative here. To rewrite this problem is -4 is equal to x plus 3, which means that x is equal to -7. Others of you are doing some distribution here, and you're getting -x. This is where I see a lot of mistakes. You need to distribute to the 3 as well. -3. So then if we add 3 to both sides, we get 7 is equal to -x, or x is equal to -7. Either way on the right side is appropriate. They both give you the same answer, but you have to find one that makes sense for you. For numbers 9, 10, and 11, we're dealing with a situation where we have Indiana Jones throwing some crystal skulls off the edge of a tall tower. I guess that's how he deals with making a bad movie. We are given an equation, and this is modeling the height of a crystal skull t seconds after Indiana Jones drops it. Okay, so that's t is how many seconds. And this looks like we're in vertex form. That means that my vertex is going to be at 2, 64 based on what I know about vertex form, and I may be able to use that later in this problem. I'd like you to notice I haven't even started to look at the questions here, and I can begin to think about what could be asked here. I also know that these problems tend to come down to either a vertex, a y-intercept, or an x-intercept. And one of the challenges is going to be to figure out which one of those I'm looking for. And in some cases, it'll be neither of those, or none of those, I guess. And that's okay, too. Okay, this is kind of going directly for this. What does the y-intercept of the graph represent? We've talked a lot about the y-intercept is the height at the start, so maybe the height before Crystal Skull is thrown, so maybe of the edge of the tall tower, because that's where Indiana Jones is standing throwing these crystal skulls. What is the highest point that a crystal skull reached? Okay, as soon as I see highest point, I want to think vertex. How many seconds did it take to get that high? This is asking for both parts of the vertex, so we have to figure out what these things mean. We know that the x value is going to be t, that's going to be seconds. So it takes 2 seconds to get that high, and the output is going to be how high it is, and that's 64 in meters. Okay, part 11, how high was the crystal skull after 6 seconds? So if we've got h of 6, that's what this is asking us to plug this in. And when we do that, we get -4, and 6 minus 2 squared plus 64. Using appropriate order of operations, I've got to do the parentheses first. So that's -4, 4 squared plus 64. Next come the exponents, so it's -4 times 16 plus 64. -4 times 16 is going to be -64, plus 64 is equal to 0. So 0 feet is how high it is, and the second part, I guess that's why this asks, why does that mean? I like how I say why this asks instead of why I asked, because I wrote the problem. But that's okay. And if 0 feet, that means it hit the ground. And that's at 6 seconds. Cool. Looking at the next section, which is based mostly on factoring, we also have to do some solving here. You're asked to find all zeros for problem 12. The first thing I need to know is that if I'm looking for zeros, I have to set this equal to 0, and then I can begin solving the problem. Just like the absolute value equation on the other page, we're going to try to get the weird part, in this case the squared part, by itself. I'm going to minus 100 to both sides. We get -4, x minus 4 quantity squared. And when we then go to divide by -4, we get 25 is equal to x minus 4 quantity squared. We know to get rid of a squared, we take a square root. This comes to our second similarity with absolute value equations. We're going to have a positive version of our answer. 5 is equal to x minus 4. And we're going to have a negative version of our answer, which is -5 is equal to x minus 4. And that's because when you take your own square root when you're solving an equation with an x, we don't know if this is dealing with the positive or the negative version. Squaring something kind of hides that, so we have to deal with both if possible. When we solve the left side, we get x is equal to 9. Solving the right side, we get x is equal to -1. For number 13, I've got to find all zeros. I'm going to do the same thing I did initially. As soon as I see the word 0, I'm going to set this equation equal to 0. So 5x squared plus 6x plus 1 is equal to 0. I notice that I've got 2 x's in this situation, so I can't use a square root. That means to me that I've got a factor, which is going to be the most common thing that we do in this section. So I'm going to start with a times c, and that gives me 5x squared. B is going to be 6x, things that multiply to 5 and add up to 6. I'm going to start with 1 times 5, because 1 times 5 is 5, and actually 1 plus 5 is also 6. On our first try, we get ones that work pretty well. I'm going to break this up and rewrite this as 5x squared, and that's going to be plus 1x plus 5x plus 1 is equal to 0. I'd like you to notice that the 1 and 5 add up to 6, and that's why we broke them up here in that fashion. I'm going to factor each piece now. 5x squared and 1x, I know that 5x squared is really 5xx, and 1x is really just 1x. They both have only an x in common. And I can undistribute that, leaving me with 5x and a plus 1. If I were to trace this back, 5x times x is 5x squared, cool, and x times 1 is 1x. We're cool with both of those. Undo those. Okay. Looking at my next set of parentheses between 5x and 1, that's really like 5 times x, and then really just 1. I guess I could do this times 1, and there's really nothing in common, so I can just deal with that with a 1 times whatever this is, which happens to be 5x plus 1. Very quickly we can see that our two parentheses are the same. That means that we can further undistribute these. In other words, we're going to combine 5x plus 1. Both of those, it's kind of like playing a memory game. When you find 2, that means one set. And they're going to bring those down to make that single first parentheses. Whatever is left over, in this case, it's going to be an x and a plus 1, go in my second parentheses. I'm just going to bring down my equal 0, because I'm being a little bit sloppy here with that. And from this point, we've got to solve each part. So we get 5x plus 1 is equal to 0. And we've got x plus 1 is equal to 0. Minus 1 to both sides, we get 5x is equal to negative 1, which means that x is equal to negative 1/5. You can leave it like that or write that as negative 0.2. And x is equal to negative 1. Those are my final answers. For number 14, which is really this entire bottom half of this page, kind of spread out, the first thing we've got to do is to write this in factored form. So I'm going to do the same thing I did just up above. I'm going to do the a times c and add up to b. That's going to be 32 and add up to 12. Okay. Well, 32, 1 times 32 doesn't work. 2 times 16, nope, that gives me 18. 3 times, okay, 3 doesn't work. 4 times 8, and 4 plus 8 is 12. All right, so I'm going to do this as x squared plus 4x plus 8x plus 32. And 4 plus 8 is 12, so that's where that comes from. Between x squared and 4x, I can just take out an x, and that leaves me with an x plus a 4. Between 8x and 32, both of those are divisible by plus 8, and I'm left with just an x and plus 4. Okay, I notice those are the same on the inside again. That's what I want. And that gives me x plus 4 and x plus 8. I'm going to rewrite this as just having an n of x equals, because that's what we had in the original problem. This is all this is asking you to do. Factored form is basically just getting these two pieces factored out, and we're going to use those a little bit later. Identifying all zeros, that's when 0 is equal to x plus 4 times x plus 8, and that's going to give me x plus 4 is equal to 0, which means that x equals negative 6, and by negative 6 I mean negative 4. Whew. And then we're going to have x plus 8 is equal to 0, which means that x equals negative 8. I'm just going to start sketching these things on my graph. I know I'm going to need those a little bit later. Here's negative 4. Here's negative 8. I'd like you to notice I didn't put any tick marks. That's just to kind of keep this graph a little bit loosey-goosey. We're going to have some other things we have to deal with big numbers as we go. To find the vertex, I know this is going to happen in the middle of the zeros. If you're wondering where my Freudian slip of negative 6 came from a few minutes ago, it was from here. So if I've got negative 4 and negative 8, exactly in the middle of these two would be negative 6. The math for this, if you want to do it out, would be the average. So I'm going to add these two pieces together and then divide by 2, and that also gives me negative 6. Which is all fine and dandy, but all that does is give us an x-coordinate. To actually get the y-coordinate, we need to use the equation. So we're going to have y equals, I like using the factored form, but you don't have to. I find it a little bit easier to work with. Negative 6 plus 4 and negative 6 plus 8, whew, which is negative 2 plus 2, and when I do that I get negative 4. That's my y coordinate. That means my vertex is at negative 6 comma negative 4. Okay, for the y-intercept, we need to find when x is 0. I find this easier to use my original equation, so that would be 0 squared plus 12 times 0 plus 32, which is 32. Some of you use the factored form, and again, that's totally fine. That would be 0 plus 4 and 0 plus 8. And if I do those, I get 4 times 8, which is 32. Some of you have kind of abbreviated this to just multiply the numbers at the end. If there were a number in front, you'd have to multiply that also, so be a little bit careful, but generally that's a good idea. You're zeroing out the x's, you're only including the number parts. So there's 32. The sketch of this graph would go through my zeros, make a nice U, and somehow hit 32. My graph is definitely not to scale. With these numbers, they probably won't be to scale, but that's okay.